Welcome back to another episode of Learning Derivatives, where I'll be showing you how to derive logarithms using the quotient rule, Leibniz's notation. So here we have a function, y, and it equals log to the base of a, x. A is our number and x is our variable. So when we derive this function, we get 1 over x ln a. So the a is a bit like a 10, a 13, an 11, just a number, and therefore, if you add log to the base of an to the base of a number x, when you derive it, you get 1 over x multiplied by the natural log of that base. I'll do an example in a sec. But here's the quotient rule, where we have a function, and within that function we have two functions, one divided by another. When we derive it, we end up with the second function multiplied by the derivative of the first function minus the first function multiplied by the derivative of the second function all over the second function squared. These are the main rules we'll be focusing on, and let's just get onto an example. Example 1. So we have y equals log to the base of 10x over x cubed. We have a function over another function, therefore we will label them as such. We'll label u as log to the base of 10x, and we'll label v as x to the power of 3. If we write out the formula for the derivative following the quotient rule, we get v multiplied by derivative of u minus u multiplied by the derivative of v all over v squared. This says that we need to find the derivative of u and we need to find the derivative of v. That doesn't look like a v, but I hope because I said a v, you know what my bad writing looks like. Anyway, so if u is log to the base of 10x, then the derivative of u would be 1 over x ln 10. Just like before, you have log to the base of a number, x. When you derive that, you get 1 over x multiplied by the natural log of that base, or that number. And x to the power of 3, derive that, just 3x squared. Filling this in, v, x to the power of 3, multiply that by derivative of u, which is 1 over x ln 10, we minus by u, which is log 10 to the base of 10x, multiplied by the derivative of v, which is 3x squared, all over v squared, which is x to the power of 3 squared. Okay, let's simplify this a bit further. Okay, dy dx. Okay, because there's a to the power of 3 here, and there's an x, when we multiply it, we'll be bringing it on top. So essentially, it'll be x to the power of 3 divided by x multiplied ln 10. So we can get rid of the x and take 1 off the power and make it a 2. So that means the first part will look like x to the power of 2 on ln 10 minus log 10x multiplied by 3x squared. That's just, you can rearrange it to make it look a bit neater, but you can generally leave it as is. But it's all over x to the power of 3. We can expand this out and get x to the power of 9. And from there, x to the power of 6. I'm not very good at math. Lol. Okay, so now we have this. We can simplify it a little further. Essentially, we can actually, I don't know if you know this, but because we've got a fraction on a fraction, we can essentially bring the ln down, but to bring that down, we would have to split. I'll write it, and then you see if you can pick it up. Okay, so what I've done here is I've brought the ln 10 under, but I've also separated it because I want to focus on this side and I want to focus on this side. So I've separated, given both sides x to the power of 6. That way we can take the x squared off both sides, take 2 off the bottom and make it a 4. And so if we rewrite it, we end up with 1 on x to the power of 4 ln 10 minus 3 log to the base of 10 x all over x to the power of 4. The reason I did what I did here, if you don't know, is I basically, when you have, I'll do a quick bit. When you have a fraction, say 1 over x, that equals x to the power of -1. Therefore, if you have x squared ln 10, essentially you can have x squared and then bring the ln 10 up, and just have it to the power of -1. So that's what I've done. Because essentially, when you have something to the power of a negative, you can bring it under. So that's what I've done here. I just skipped a step up here when we transition from here to here. What I've done is I've made this a negative power to bring it up, and then once I've gotten rid of the x, I brought it down, back down, just like how I would here. I hope that makes sense. That's just about as good an explanation as I can give, but that's generally how it works. So let's get on to another example. That's there is, I'll finish this one first, obviously, but that there is the first derivative of this function there. Okay. Now for another example. Let's go y equals sine x over log to the base of 8x. This stuff isn't really tricky, it's just rules and following those rules. If you follow the rule correctly, you end up with the correct answer. When you're doing derivatives like this, when you're not actually doing applications or problem solving, you don't really run into too many problems if you follow the steps correctly. right? Okay, so here we have u on the top, sine x on the top, and v on the bottom, log to the base of 8x on the bottom. So we will label them as such. U will be sine x, and v will be log to the base of 8x. Again, write out the derivative, which is v multiplied by derivative of u minus u multiplied by the derivative of v all over v squared. Just like before, we have to find the derivative of u and the derivative of v. Sine, when you derive it, it goes to cosine. No problems there. When you derive log to the base of 8x, just like before, 1 over x multiplied by the natural log of that number, or the base, which should be 1 over x multiplied by ln of 8. Finish this off. V log to the base of 8x multiplied by derivative of u cosine x minus u sine x multiplied by derivative of v multiplied by 1 over x ln 8. V squared log to the base of 8 x squared. Okay, to make the other example seem a bit more clear, I'm gonna do it on this one, just to this fraction here, just in case you hasn't quite stuck. So that's done, but I'm going to simplify it. You should always try and simplify and try and make them look as neat as possible, but you know, still staying correct, obviously. So if we split it and put a log to the base of 8x squared on either side, we can focus on two separate fractions. Well, two fractions with a minus sign in the middle. Okay, this is what I mean. I've just made the fraction to a negative power. It's still multiplied to sign, and it's still over log to the base of 8x squared. The only thing is, now, because it's a negative power and it's on the very top, I can essentially bring it to the bottom and make it a positive power. That's all I was doing before. Nothing too tricky, just rules. Okay, if we simplify this a little more, log to the base 8x over log to the base 8x all squared, we can take the power off and take this off altogether. So we're taking one off the power and we're taking one off this one, which will get rid of this and leave this the same. Rewriting it will be cos x all over log to the base of 8x. That's one side done. Minus, simplify this side. Nothing to simplify except bringing that to the bottom. We'll finish with x ln 8 log 8x squared. See, all I did was just bring it to the bottom. The same as it is, I just made it a positive, to the power of a positive 1, which I just got rid of the power of the positive 1 because you don't need to write it. Everything, not everything, I shouldn't say that, but most things obviously to the power of 1. Anyway, that there is the derivative first derivative of this function up here. Let's do another example. Okay, example 3. This one is a little bit easier. We'll have y equals log to the base of 7x over e to the power of x. Again, we have our first fraction over our second fraction. We'll label them as such. U can be on the top, so log to the base of 7. X is on the top, so we'll label them as such. And v we'll label as e to the x because they're both on the bottom. Labeling has zero effect on the equation itself. It just, you label them to make them smaller and easier to work with, because when you write out the derivative, you have v multiplied by derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. That's, as a rule, it's easier to write things like derivative of u with respect to x, knowing that the derivative of u, we've just replaced u. Anyway, I'll get onto it. I'm rambling too much. Okay. U is log to the base of 7x, and therefore the derivative would be 1 over x ln 7, because when you have log to the base of 7x, you end up with 1 over x multiplied by the natural log of that base, which is 7. V is e to the x, the derivative is e to the x, no problem there. Filling it in, v, e to the x, multiplied by derivative of u, 1 over x ln 7, minus u log to the base of 7x, multiplied by v, multiplied by e to the x, v, derivative of v I should say, all over v squared, which is e to the x squared. Okay. Simplifying it. We get, if I factor this out, the e to the x, I can essentially factor it out to the front because it's multiplied on both sides of the minus side. E to the x, 1 over x ln 7 minus log to the base of 7x all over e to the x squared. I've just factored it out, bringing it out from both sides and multiplying it. I'm multiplying e to the x to the whole thing, so if we were to expand these brackets we would get that. Anyway, so now that we've got e to the x on its own, and it's over e to the x squared, we can take 1 off this power and take 1 off this power, which will get rid of the whole thing. And we'll be left with 1 over x ln 7 minus log to the base of 7x all over e to the x. I'm going to simplify this a step further just by bringing this under, and we'll end up with 1 over x e to the x ln 7 minus log to the base of 7x all over e to the x. And that is the first derivative of this function here. Thanks for watching. I hope this helped.